So the concept that we are going to see in this video is about dequeue. Dequeue is deleting an element from a queue. So this will help you to understand how programmatically you can implement the concept with step-by-step execution. So yes, the operation that we are going to see is delete operation from the concept queue. And here we are going to understand this particular program or this particular function so that it becomes easier for to implement it. So we are going to understand how this each line of code is executed. So when I want to delete my queue, the very first line, now here in my if statement, front equal to -1. Now this condition happens when, if this is your queue, right, my initial value of front and rear is -1 when my queue is empty. So I'm trying to check that if my front is equal to -1, front is something that works on deletion, rear works on insertion. Remember, front works, you can check our previous video where I have mentioned it, that your front would work on deletion and your rear works for insertion, right? And in both the cases you're going to increment. When I want to insert, I'll increment my rear. Where I want to delete, I'll increment my front. So here I'm checking the condition of is empty. Why? Because if I'm deleting an element and if there are no elements in my queue, I need to check that. I need not keep on pulling out the element. If there are no elements, it should show me a message that queue is empty. And when will I know my queue is empty? When my front is equal to -1. Rear is used for insertion, so we are not checking rear, we are checking front. Okay, so if my front is -1, that means my queue is empty. Now next, if my queue is not empty, now how will the deletion happen? So as we already know, 10, 20, 30, 40, your rear will be pointing here because rear goes on incrementing as and when you insert. So the last element that is inserted, your rear will be pointing there. And your front, which was -1, as and when you insert your first element, your front points to the 0 location. So now when I want to delete element, what am I supposed to do? Now in this case there are some extra lines added. I want to even display user what the element was deleted. So I have taken an integer num, and in this what am I going to store? The value that was supposed to be deleted. So how am I storing the value? Num is equal to q of front. So wherever my front is pointing, q is the name of my queue. So wherever my front is pointing, that value should be put in num. So what I have done, q of front, whatever value is there at front, because my deletion will always happen from the front, right? So whatever is value at the front, that I'm storing it in num, and then I'm deleting the element, and also I'm printing it to the user that deleted element is num. So here in this case I cannot delete the element and then retrieve it for the user. I need to show the user first that which element is deleted, and then I need to follow the steps. So these are extra steps. Okay, these are some extra steps that you're just informing user to know that okay, this is the element deleted. Actual logic falls here for deletion. Now what is the logic? Whenever I want to delete the element, my front will be incremented. So my front, which was pointing here, will be incremented. My front will point to this location, and automatically my element will be deleted. Front plus plus. The moment I do front plus plus, the previous element will be deleted. So this is the actual logic. So it's only one line code for deletion. Now what is this line doing? Suppose, now let's try to understand what is happening here. Okay, suppose my first element was deleted, my front is pointing here. Now again I want to delete the element. I increment my front, previous element is deleted. I increment my front, previous element is deleted. I increment my front, previous element is deleted. Can you see this condition? Front and rear are at the same place. That is the last maximum size. Now again, if the user is calling delete function, calling delete function, as per the logic, my front is going to increment. As per the logic, my front is going to increment. So if my front is incremented, I have to check this condition also. And what is this condition saying? That if my front is greater than rear, in this case it is, right? 0, 1, 2, 3. My rear is pointing at 3 and my front has surpassed rear. So my front is greater than 3. Front is greater than rear. Yes. So I am supposed to pick up both the elements, because once my front is incremented, my previous element is deleted. So in this case, what has happened? My front and rear should be pointing back to -1 because my stack is empty. So this is the line. Very simple. The actual code for deletion only lies here. That is front plus plus. The moment you do front plus plus, the previous element is deleted. But with that, there are things that are need to be checked. The very first is your queue empty? So we check that condition here, because we cannot delete any element if the queue is empty. And the second thing that you have to check is, have your front exceeded your rear? Front has exceeded your rear. If that is the case, I know that my stack is empty, because my rear doesn't move, right? Rear would be the last. And if front is exceeding, obviously my queue is empty. Let's try to understand with one more example. Suppose I have not filled my queue completely. 10, 20, 30. Maximum size is 4 elements. 4 elements, out of that 3 elements are put in my queue. My front, as per the concept of queue, my front will be the starting element, and my rear will go on incrementing as and when I insert. So for now, my rear will point over here. So for me to delete the element, increment your front and delete the element. Increment your front, delete the element. Increment your front, delete the element. Again, check the condition. Is my front greater than rear? Yes. So my stack is empty. I'll pick my both front and rear from here and put it here, which is -1. And -1 means what? Empty. Okay, so that's very simple insertion and deletion for queues. Okay, there are few more functions that are pending. We'll see that in our next videos.